Hi, I went to the lecture on November 30th by Peter Juncker, and the main concept about it was that physics is all around us. You can see examples of physics and how it's applied everywhere, even in mundane things such as breakfast, which is what this whole lecture was about. He talked about three main things. It was the coffee ring effect, scrambled eggs, and the Cheerio effect. And so the first one, the coffee ring effect, he talked about how the reason that when a coffee stain is left, it's very dark on the outsides and pile ups on the outside and not in the middle. So what happens is there's a bubble of the coffee like this, and then instead of everything going in together and evaporating from the outside in, what happens is um, everything on the surface evaporates, but the surface tension has to be kept the same. So when this when this part gets evaporated a bit, the surface tension needs to be minimized because or the surface area has to be minimized because of surface tension. So this comes back down a little bit, and it kind of maintains the same shape throughout the whole thing. So the many particles inside the coffee will move toward the outside, and so that is the coffee ring effect. The next one is scrambled eggs and why they, when they're heated up, instead of becoming from a solid to a liquid or liquid to a gas, it goes the other way and it goes from a liquid, what appears to be a liquid, to a solid. And so the reason that is because there's a bunch of proteins in the egg, which is what most of it's made out of, is protein, and they start off as little tiny coiled up proteins, entities, like individual particles. So they're easy to move around and stuff. But then what happens is when they're heated up, those proteins get unbinded and are a bunch of floating around things, and they bind to each other, and so that forms a network that makes scrambled eggs sort of a mesh almost of scrambled eggs, and so they become hardened almost, and it does not, contrary to popular belief, have to do with the fact that the water from the egg is being evaporated. It's just that the proteins get linked together. Um, and so he mentioned how he hooked it up to a UTM machine, and so he tested the elasticity of the objects and how the scrambled eggs after they've been boiled are a lot more elastic. So the last thing is the Cheerio effect, and what happens? He mentioned, he was explaining why Cheerios, when they're in milk, when a bowl of milk, they kind of attract towards each other and other such cereals, and so the reason because of that is the fact that Cheerios are a lot less dense than milk, and so they want to get as high up on top of the milk as they can, and so the milk actually has adhesive properties, and so it goes up and tries to bond, like it is attracted to Cheerios. So there's a little lip right here, and so when they get close to each other, because of the surface tension of milk and the fact that it has to be more, it wants to minimize surface area. When they get closer to each other, the two lips kind of come together and just form one between them, so they come together. And the same thing happens when there's something that's even more dense than milk. For example, he mentioned paper clips. So when they're sitting in water or milk, this is the paper clip. It kind of pushes it down, but the surface tension holds the paper clip still there. And so when two paper clips get close to each other, the dips kind of another again because of the surface tension, they are attracted to each other. So one thing that I found really interesting about the lecture was that a ton of people have tried to figure out the reason um, why the coffee effect happens and how to change the coffee effect. It's interesting that when you change the shape of the particles inside the liquid from spherical to elliptical, this coffee effect is removed pretty much because the way that they bind together, or the way that they form together and collide, it reduces that. Um, and one idea that wasn't stated in the lecture that I kind of did some research on was more about surface tension. And I know I researched milk because that's a part of breakfast, and so I saw a cool video about how when you put soap in milk, all the particles, and it's easier to see this when you put colored dye in it. You can see that there's a bunch of movement going on and proteins moving around and stuff like that, and that's because soap is very polar. So it's hydrophobic piece on one end and not on the other, and so the hydrophobic piece will try to bind to proteins, and hydro the part that likes water will absorb into the water, and so so there's a bunch of movement within the milk. Yeah, thanks.